So we're now adding this to naught to that, and we get this, right? And similarly, we take the fourth one, this one, here it is, and we add this to these, and we get that, right? Actually, I should have mentioned that. This is normal, but because have a look at it. If you write it out in short, it's of this form, okay. And the binary operation between these elements is plus, and so you're just adding numbers effectively. And a plus b is the same as b plus a. So this is a group, and it's an abelian group, and therefore it's normal. All abelian groups, their subgroups are normal, right? Because of being abelian. All right. Now I'm going to go off at a tangent a little bit. Remind you of the theorem, or part of the theorem, that I've used in the previous session. It's very, very useful, and I said earlier that we would use it again, that it is extremely useful, very handy device, and we'll use it again here. And this theorem allows you, it gives you a technique to kick out, to eliminate repeat cosets. Right? Now, here it is again. Okay, the basic idea is, well, I'll just say it in words before. If you have an element from your big group G, big G, if you have an element that belongs to two different cosets, like G1H and G2H, so if you have an element that's in both of those two cosets, little g1h and little g2h, then those two cosets are the same. They have the same elements. Right? That's essentially what this is saying. Okay? So I'll say it again, sort of reinforcement. If you have an element that belongs to two different cosets, like G1H and G2H, those two cosets are the same. Right? So you can look on one of them as a repeat, throw it out. Just use the other one. Okay? All right? So that's essentially what it's saying. Now the proof of it is, if this element belongs to coset A, let's say, this particular coset, then this theorem says that this coset A equals XH, where H is your subgroup, right? So if X belongs to the coset, that coset is XH, right? So if you have an element that belongs to two cosets, A and B, then A is XH, and B, coset, so coset B is XH. Now XH are the same for both of them, therefore A and B, cosets A and B must be the same, right? And I'm saying that in other words, is if an element of G, big G, if an element belongs to two cosets, different cosets, like coset A, coset B, then these two cosets, they're the same. They have the same elements. They're the same coset. Right? All right. Now let's use that. Okay. Now look, here is a coset. It's the coset from this element. That's an element of this, right? What are the elements of this? Well, here, right? It's the four elements of this are 0, 0, 1, 0, 2, 0, 3, 0. That's H. Okay. Now, and we're taking the first four elements of big G. These four, and we're forming the first four cosets, right? So we have 1, 2, 3, 4 cosets using the first 4 little g's, first 4 elements of your big group, big G, right? And look at the results. Notice something? Let's, doesn't matter, it doesn't really matter which one we choose. We've got 4 choices. But let's say we choose this element here. So this is an element that belongs to the coset. Right? This is a coset. This whole thing is a coset. Okay. Now this element, this ordered pair, naught, it belongs to this set. Right? That's obvious. It's a member of this set. Okay. But look, it's also a member of this set, or coset, because it's a coset. This element belongs to this coset and belongs to this coset. It also, here it is, again, it belongs to this coset. And again, here. So this element here belongs to all 4 cosets. And therefore, using theorem 46, second part, this A equals XH. So using this logic, we have not just 2 cosets the same, we have 4 cosets the same, right? by using this reasoning here. So we now have 4 cosets that are equal. So we have 3 of them redundant. So just throw out 3 of them. And which one? Well, doesn't really matter. You can choose any one of the 4. And that then becomes an element in your quotient group, and your choice, which one of those 4, will influence your group table. So it doesn't really matter. Let's just choose the first one. Okay, so let's just choose this one. So that becomes our coset, and the other 3 just throw out because they're repeats. They're repeats because the sets, cosets, are the same. I mean, you can just see, right? I mean, the order's a bit different, but they're the same element. They're the same set, right? You can rearrange the order of elements in a set. It's the same set. Okay. So these 4 cosets are equal. So let's just choose the first one and throw out the other 3 because they're repeats. All right. Okay. Now you can probably see where I'm going with this argument. Now let's take the next 4 elements, little g's, of your set big G, right? The next 4, and they will have the form 0, 1, 1, 1, 2, 1, 3, 1. Right? The next 4, the second block of 4 elements of big G. Right? So here, see, 0, 1, 1, 1, 2, 1, 3, 1, and form their cosets. Right, so you're just adding this now to your H, your subgroup. So 0, 1 added to that will give you, well, so 0, 1, 1, 1, 2, 1, 3, 1. Okay, and similarly for the rest. Now look, it's the same story as you had here. Have a look. These 4 sets, cosets, are the same. All right. Therefore, these 4 cosets are equal. And again, using this logic, we can eliminate. We can throw out 3/4 of them. In other words, 3 of them. And let's keep the first one because it's sort of easier, right? So let's keep this one as the coset we will use for our quotient group, right? And we have 3 copies in a sense, and let's throw out these 3, right? So far we now have 2 disjoint. I mean, think about it. I mean, compare this one with this one, this coset here with this one. Now, can you see the disjoint, right? Because these all have 0s here, and these ones also all have 1s here, right? So this coset is disjoint, different, right? There are no elements in common. between this coset and this one. You know, because you have ones here in the second position of the pair, the ordered pair. Here you have zeros. Okay. Now with the same logic, we can then take the next, so be the third block of 4 elements of big G, and we'll just get the same story again and again, and we can do that 8 times, right? Because we have 8 blocks of 4, and so okay, so this was our second coset that we chose. We chose to take this one, and we'll have the same story when this is 2 here, right? 0, 2, 1, 2, 2, 2, 3, 2. Okay, so our third coset, we'd have a 2 here. Our fourth coset, we'd have a 3 here, and so on. Now the general form, we will end up with 8 cosets of this form, where for each block of 4, we're taking the first one, like this one, and so on. So we'll always have a 0 here, and then the number here will be 0, 1, 2, 3, ... 7. It gives us 8 cosets, right? So we'll have 8 cosets of this form, where this integer here, the second in the ordered pair, ranges 0, 1, 2, 3, ... 7, right? So here are our 8 cosets.